final section for now is on electronic configurations, and as you'll see, this is often a question that comes up in multiple choice, though you do see some written answers for it as well. So first one here, it's a question that's kind of not tricky but not easy either. It's easy to get tripped up on. It's giving you some electronic configurations and asking which one of those has got 2 unpaired electrons. It's not that obvious to see it just by how it's written in SPD notation. It's helpful if you see it actually in the box notation which we've looked at. It's in other words, giving each orbital a box and showing where the electrons are put in, because that actually shows you what's paired and what's unpaired. So I'm going to just do, that's a bit of a long box, for up to 2p, because we'll soon see that that's all actually we'll need. I'm not going to draw it in just because I have to do it every time, but for 1s2, 2s1, that would look like, so 1s2 would be 1 up, 1 down, that's not unpaired, and 2s1, that's no good either because that's just 1 unpaired electron. Second one, 1s2, 2s2, 2p3, so that looks a bit more promising, so 2s2, that's filled up, and then 2p3, remember each one goes in its own box first before they pair up, but no, that can be right, that's 3 paired electrons. Option C is 2p4, so that's the fourth one we're going in. That looks a bit more promising. I've put them in the box here. I've got 2 unpaired electrons in a 2p orbital. There's nothing in that box with these 2 electrons. That's 2 unpaired electrons, that's the answer. Just to check the final one. 1s2, 2s2, 2p6, that's a full orbital, that's not unpaired. 3s2, that's also a full orbital, that can't be unpaired. 3p5 is the last one, so if I do like a 3p5, I'm not going to do all the in-between bits. 3p5 would look like this. That's only 1 unpaired electrons, that can't be the answer either. So C is the correct answer. Question 13, a positively charged particle with the electron configuration 2, 8, so it's going back to kind of GCSE kind of configurations, which they can do, is aluminium ion, fluoride ion, oxide ion, and potassium ion. So easy way to do this is almost to treat it like a GCSE question. And for those elements they've listed, I'm going to work out what their electron configuration is just off the periodic table from their atomic numbers. So aluminium has got 13 electrons, that's 2, 8, 3. Fluoride is in the second period, so it's got 9 electrons, that's 2, 7. Oxide is 2, 6, right beside fluorine. And potassium, it's quite a big one, 2, 8, 8, 1. So we're looking for something in the form of positively charged particle with electron configuration 2, 8. So if it's positively charged, it's going to have to lose electrons to get down to 2, 8. So that immediately rules out fluorine and oxygen. And they're not really going to form positive ions anyway, but even if we force them to, they're going down in electrons, that gets them further away from 2, 8. So between aluminium and potassium, I mean, you could argue maybe if you take loads of electrons out, it's going to go to 8, but it's not really. It's going to go to 2, 8, 8 when it forms this full outer shell. But aluminium, if it loses 2 electrons, it's going to form 2, 8 with the P plus ion. So aluminium is the correct answer there. Which of the following represents the electron configuration of calcium in the ground state? With this sub-question, you can get a bit muddled looking at them. So I always think the best idea is just try and do it yourself, and hopefully your answer will match up with one of the answers. Otherwise, you'll be led by one of the traps in the question. Calcium off the periodic table has got 20 electrons because its atomic number is 20. So if I just put them in my rules as normal, 1s2, 2 electrons, 2s2, 2p6, 3s2. Then we're going to go to 3p6, so that's count my electrons here, 2, 4, 10, 12, 18, 2 more electrons. Have to remember it goes into 4s now, that's the wee trap of this question. It's tempting to go into 3d2, which is one of the options here, that's wrong. 4s is filled up for 3d, it's the other thing you have to remember. Looking at the answers, it looks like the only standard answer is B there, it looks correct to me. Okay, 15, we've got a written question. A bit of drawing. Draw the shape of an S and a P orbital. Remember, that's not an art exam. S orbitals are just spherical shapes, they're kind of just like a circle. And then P orbitals are dumbbell shapes, or like figure of 8 shapes. So that'd be a perfect P orbital, even though it's not a great picture. Write down electron configurations of a carbon atom in terms of sp electrons. So it's the same question as we've done on this previous one. So carbon has got 6 electrons. So I have to fit those in my orbitals. So 1s2, 2s2, 2p2 would be 6 electrons, but in the correct place. Question 16, we got a wee bit of deja vu with what we had in question 13. This is actually pretty much the same question. They've expressed it differently. It's not in terms of 2, 8, it's in terms of SPD notation. 1s2, 2s2, 2p6, which is equivalent to 2, 8. Basically, it's the same question, so actually it's aluminium again. So aluminium, if I gave you its proper electron configuration, so it'd be 1s2, 2s2, 2p6, 3s2, 3p1. If it loses 3 electrons, it goes down to 2p6. All the other ones will form negative ions, or potassium is a bit too big for this question. So A is the correct answer here again. A little bit more SPD practice for magnesium here in question 17. Use your periodic table. Magnesium has got 12 electrons, so just using your rules to put them in the correct place. It's going to be 1s2, 2s2, 2p6. Let's just check my count up here. 2, 4, 10, so I need 2 more. It's going to be 3s2. Question 18, we've got a different kind of style of showing electrons, so not in SPD notation, but in boxes, which is absolutely fine. It's showing the same information. Which of these is for a nitrogen atom? So let's just check the number of electrons. Nitrogen has 7 electrons, so it should be 1s2, 2s2, 2p3. And what you should notice here is actually all of them actually match up with that. They've all got 2 in the first 1s orbital, they've all got 2 in the 2s orbital, they've all got 3 in their 2p orbital. So there's no tricks in kind of that respect. The question is about how do you put them in the orbital, like where do the spins go? Remember the direction of the arrow shows a spin. And how do you put them into like a 2p orbital? So the first one I'm going to count out because it's not filled up the 2p orbital correctly. You always put them singly first. Remember it's called the filling up the bus rule, how you'll always sit in an empty seat before you go into one where someone already sitting. So A is not right. B doesn't look good because in your 1s you've got 2 electrons with the same spin. Remember, electrons are going to be in the same orbital if they've got opposite spins. That's the same issue unfortunately for C as well. They've all got the same spin, can't be correct. So therefore D must be the correct answer. Spin up, spin down, spin up, spin down. And these electrons are all singly occupied, which they should be before they have to pair up. So D is the answer here. Part 4, give the ground state electron configuration of the aluminium 4 plus ion. Now, aluminium, obviously, as you might be aware, is in group 3. Doesn't really like forming 4 plus ion, but it's just telling us in the question has to do that. So looking at my electrons, it's got 13 electrons. So probably best idea here would be to just give me my normal correct configuration and working out from that. So 13 electrons would be 1s2, 2s2, 2p6, 3s2, and 3p1. If I take out 4 electrons from that, I'm going to take out my 3p1, I'm going to take out my 3s2, so I've got 1 electron left over, it's going to go down to 2p5. So 1s2, 2s2, 2p5 will remove 4 electrons from the aluminium configuration. Question 20. Use the boxes below to complete the electron configuration of these ions. So it's a bit tricky because they're ions. So magnesium first, so let's just actually write what magnesium is when it's normally got a normal configuration, not an ion. So magnesium normally has 12 electrons. So it's going to be 1s2, 2s2, 2p6, 3s2. Taking out 2 electrons is going to take out the 3s ones. So 1s2 up down, 2s2 up down, 3p6, 1, 2, 3, 4, 5, 6. And that's be done. So nothing in the 3s because it is the 2 plus ion. Chlorine, we've got the opposite case. So chlorine by itself normally be 1s2, 2s2, 2p6, 3s2, 3p5, and that's 17 electrons. If it's got one more, it's going to go up to 3p6. So we're going to fill up all the way up to 3p6 here. Up, down, up, down, up, down, up, down. This is going to be completely filled up as well. So everything's going to be going in there. On the final page, 21, we've got strontium being mentioned. It's a strontium carbonate used in fireworks, blah, blah, blah. It suggests to form an electron configuration for the strontium ion. This is a little bit trickier. So strontium is in group 2. So the first thing is what the formula of the ion is. So obviously it's going to have SR because that's in the periodic table. Yes, if just trust your kind of common sense. If something's in group 2, you've learned since it's our 4th year, it's going to form an ion with a 2 plus charge. So we'll go for that. In terms of the electron configuration of that, just have to use my electrons. So if I generally like to start just by working out the electron configuration just for the normal atom. This one's a trickier question because I've got lots of electrons to put in. It's probably more than you normally have to put in. 38 in a normal atom. So it's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now remember, I should write 3d first if I'm going to fill up both of them, but I'm just working out here, so it doesn't really matter. 4s2, 3d10. I remember just to emphasize, if I was writing that as a proper answer, do 3d before 4s. But let's just count up so far. 2, 4, 10, 12. 12 plus 6 is 18. 18 plus 2 is 20. 20 plus 10 is 30. So I've got 8 more electrons put in. So after my 3D is filled up, I'm going to go to 4p, so 4p6. Then I've got 2 more to put in. It's actually going to go to 5s2. So taking those two extra electrons out, 2 plus, is going to take out the 5 1. So even if you weren't sure where they were going, it doesn't really matter. So just going to write what I've got next. Remember, my final answer, I've put the D before the 4s, even though the 4s is filled up first. So final answer becomes 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6. Then part 2, suggest the meaning of the term isoelectronic. Now, whenever you see the word suggest, as we saw in the first one, generally means it's going to be a harder question. Suggest implies that something that isn't actually in your notes or in the specification. It just wants you to think and try and puzzle out from the question. So it tells you that strontium ions are isoelectronic with krypton ions. We've seen the kind of word iso before in isotopes. It means like different forms of the same element. So it's kind of meaning the word same electronic. Hopefully it's not too hard to kind of think that that just means it's got the same number of electrons or same electronic structure. So that's what they're kind of going for here. And that would kind of match up because strontium is very close to krypton. If you took 2 electrons out from strontium, you're actually matching up with what krypton's got for its electronic configuration, which would be another hint. So it's got the same number of electrons or the same electronic configuration. Then final question 22. Which one of the following elements forms an ion with a double negative charge? This means 2 minus charge. That has the same electron configuration as argon. So let's look at argon. Argon's got 18 electrons. So it's 1s2, 2s2, 2p6, 3s2, 3p6. And we're looking for something which is close to that if it forms a double negative charge. Now, calcium's close to argon. It would actually be the same as argon if it lost 2 electrons. That'd be a double positive charge. So calcium's out. Chlorine can have the same as argon. It's got 17 electrons. If it formed a 1 minus ion, that's not a double negative charge, a single negative charge, it's out. Selenium, let's see it. It's very far away from argon. It's almost like a trick question. That's not looking correct at all. Sulfur's got 16 electrons. So if one gets 18, it has to gain 2. Gaining 2 would give a double negative charge. So D is the answer there for sulfur.